One, the mole ratio in which reactants combine. And we know what are reactants, right? So those are normally the substance to the left of the arrow. In acid, bases and salt, the reactants are the acids and the base, or the alkaline and the acid. Alright? And two, we use it to calculate the molar concentration or mass concentration of one of the reactants. Alright? So, do you know what we mean by molar concentration and mass concentration? Alright, so molar.
So, molar is the amount of particles in the substance.
Units, moles per dm cube. Alright? Mass concentration. Gram per dm cube. Alright? So basically, I will know that 1 dm cube is equal to 1000 cm cube. We have to know this conversion very well also. So these are stuff that you have to remember. Alright? Now, so it simply means concentration can be expressed in moles per volume or mass per volume. Basically, that's what it's saying, right? But remember that normally we use 1000 cm cube or 1 dm cube as the molar concentration of something, of a solution. Alright? So we always try and work back to the amount of moles or the mass of the substance in 1000 cm cube of solution. Alright? To use it as the molar concentration. Because whenever we have remember that if you, at the early, I'm not certain how you were taught mole concept, right? But a mole is like equivalent to saying like 1 dozen of something. So a mole is just a term that we use to describe Avogadro's number of particles, which is 6 times 10 to the 22 or 23 particles, right?
6 times
Just
6.022.
Yeah, but I think at this level, so you can actually round off at 6, but it's 6.022 to be exact. So 1 mole equal to 6.022 times 10 to the 23. So that's a very large number, right? 1 mole is just something like, say, like 1 dozen, right? Which is just 12. You get what I'm saying? So you can always just, or 1 score. You see and see, so the mole is just basically just saying that large number there. Like, oh, if for example somebody should ask you, what do you mean by 1 dozen? It means 12 particles. 1 score would be 20 particles, right? If it's 1 mole, it's 6.022 times 10 to the 23 particles, right? Likewise, if someone wants to know half dozen or 0.5 dozen, it would be 6. If they want to know 1.5 dozen, it would be 18. You following? So in a similar scenario, if someone wants to know half mole, they just divide this number by 2 and then you will get what is half mole. If you want to know what are 2 moles of something, we just multiply this number by 2. Alright? concentration of hydrochloric acid No. So whenever it comes on to moles, concentration, volume, find out that we're going to have concentration. So CONC is concentration, right? Mole, volume, right? So the three quantities, they are interrelated. Alright? No. So what this is saying is that if we should know two of these quantities, we can calculate the third one, right? That these are they are interrelated. If we know one, it's impossible to calculate the other two. But if we know two, we can calculate the third. So if we know the concentration and the moles, we can calculate the volume. If we know the volume and the mole, we can calculate the concentration. If we know the concentration and the volume, we can calculate the number of moles. You following? So these are the three things that we will need to take into consideration in neutralization reaction, right? It still will go further over into mole concept because sometimes they will want the mass concentration, then you would have to know how to convert from moles to mass. Alright, so that will be required as well. Alright? Now, so what are these things that we have here? So this is HCl, we have the moles, which is 0.004 moles. We have the volume, which is 25 cm cube. So the concentration is the unknown. We could all deduce those information from the questions, right? From the question, right? We could all deduce these stuff from the question. So what is required, what do we have? Alright? Now, as I said before, whenever we talk about concentration, when it asks about concentration, they just simply want to know the number of moles that is in 1000 cm cube of the solution. That's basically what a concentration is. A molar concentration is just the number of moles of the HCl that is in 1000 cm cube. So if we know the number of moles that is in 25 cm cube, we can just work along and determine the amount that is in 1000 cm cube. Alright? So what I would say here is that 0.004 moles HCl is in 25 cm cube. So the question is, how many moles of HCl is in 1000 cm cube? Where did we get this 1000 from here?
That's the
Molar concentration. I want to know about concentration is the amount of moles that is in 1000 cm cube. I remember that as I had down here, 1000 cm cube is basically as 1 dm cube. So if you see in the book, they will give you like a concentration in moles per dm cube. It's just simply the number of moles that is in 1000 cm cube of solution, right? So it simply means that if we should cross multiply here, then it's x moles of HCl be equal to, this is 0.04 moles times 1000 divided by 25, right?
Alright, make sure you're not dividing the 25 by 1000.
Yeah, but it will work out the same.
Okay, so
And what do we get here? Cross multiply and just type in regular maths. So this is not chemistry, no, this is just maths. So 0.004 times 1000 divided by 25. What do we get here? Oh, we're going to need calculation. We're going to need it for the exam, alright? I remember that I'm just making up these questions from my brain. Alright, just to show you the interrelation.
-16, so.
Divide by 25. And this is 0.16
Yes, sir.
moles per dm cube. Why do we have dm cube here and I can just write dm cube? Because 1 dm cube is equal to 1000 cm cube. And what we found here is the number of moles that is in 1000 cm cube. So it's the same thing as the concentration. Alright? Alright, take this from the board and let's just work another one. Alright, so in this case the concentration was the unknown. And remember that we have to know how to figure out each reactant before we can put the whole equation by itself. Work out the equation. So we're going to do it like reactant by reactant. Alright? Alright, just to stretch your brain a little further. Remember that I was telling you that 1 mole is just equal to 6.022 times 10 to the 23 particles. So if we're talking in terms of hydrochloric acid particle, 1 mole would be 6.022 times 10 to the 23 hydrochloric acid molecules. Alright? Now, as you can see, the concentration of this would be 0.16 moles per dm cube. So it would be 0.16 moles. So if we want to know the number of hydrochloric acid that we have in in this concentration, it would be this moles times that number of particles, which would give us the amount that we want. Alright? Because 1 mole would be 6.022 times 10 to the 23. So 0.16 moles would be lower. Alright, so it's like would be this times that number. Alright? There's the same concentration that we have here. Convert same concentration that you have choose here, Mr. Hardy. Convert 0.32 moles per dm cube NaOH into the mass concentration. Remember that mass concentration is grams per dm cube. So instead of moles per dm cube, we want that in grams per dm cube. No. So the things that we need to know here is that we can interrelate mole mass and molar mass. Next 3 quantity on the board again. Alright? Remember that mole is like the central point to all the different stuff. Alright? So we can relate moles to mass to molar mass. Alright? Now, what's the molar mass? The molar mass is the relative molecular mass of the compound expressed in grams. Alright? So this is the mass of substance expressed in grams, right? 6.022 times 10 to the 23 particles. Alright, so look at these three quantities, right? What do we have from the equation and what from the question and what we don't have? Because we always must have two and we don't have the but say the first know how to identify which two quantities we have and which one we don't have. We have the moles, right? 0.32 mole. We have that one. Do we have the mass or the molar mass?
No, sir. Can't get it though.
Which one we can get?
Can't get molar mass.
Good, we can get the molar mass. We can remember that the molar mass is the relative molecular mass or the relative formula mass in terms of a compound expressed in grams. Alright? So the relative molar mass of sodium hydroxide is going to be equal. Sodium is what? 23 plus oxygen is 60.
16.
Plus hydrogen is 1.
Yes, sir. Yes, sir.
So this is sodium, this is oxygen, this is hydrogen. So that would be 40. That's what we get. So as you can see, we would have the moles, we have the molar mass, so we can calculate the mass. Alright? And then remember that if we calculate the mass, then that would now be the mass concentration. Because it would be the mass in per liter, or per 100,000 cm cube, or per dm cube. Alright? So it simply means that from this molar mass here, it's saying that 40 grams of NaOH is equal to 1 mole. Following?
Yes, sir.
40 grams of sodium hydroxide is equal to 1 mole. Right? So X grams of NaOH is equal to 0.32 moles. Right? It's gonna be X grams what do we have here? You have a calculator. You have a calculator on your phone. So 0.32 times 40 divided by 1.
12.8, sir.
12.8,
Yes, sir.
right? Therefore, the mass concentration of NaOH is equal to 12.8 grams per dm cube.
Sir, you divide by 1. Is it necessary?
Yeah, because I want to keep it consistent with to cross multiply. Alright? Because I want to show that this one is coming from. Alright? But it will be the same thing, of course. Alright? Because the number divided by 1 is the number. Alright? Let me see if I can get a real question.